Okay, let's start our webinar. Today is next session of our series webinars related to front-end architecture and front-end development. And agenda for today's meeting is to remind us that our front-ends works above Backbone and Chaplin.js. Discuss a bit why our application is not a full single-page application, what are AppModules and global views, how works application starting flow, what are page components, how promises tree and layout is initialized, and then we will have a question and answer session. As you already know, our Aura application frontend is based on backbone.js and Chaplin.js. These libraries are great and flexible. They allow us to develop view to model and model to view relation. However, they both lack something that we need. Backbone proposes to create a map of URL max and define method for each of them. Method will be executed with router parameters once new URL matches the pattern. And the route method is responsible for creating all views and models used on a page. Pretty the same approach is proposed by Chaplin, although it is more enhanced. Here, application is proposed, so we have application level, and action methods are grouped by controllers, and controller modules can be loaded in runtime. This approach allows to build more complex applications, but there is still a pitch point, and it is the controller that knows everything about the page, what it should consist of and how it should look. Building flexible application where each page can be extended or completely changed by any bundle. There isn't a single place where we can define page structure. In our case, it is defined in runtime based on Symfony configuration and templating language and layouts. HTML blocks are partially prepared on the server, and on the client side, page are updated by regions. So there is two rendering phases. First is on the server, and then on the client side. In other words, it is not a full single-page application. And it is done intentionally to build kind of isomorphic application and reach two goals. First is to get advantages of web pages. Response for direct page requests have to return most of HTML ready to be rendered in browser or processed by a search crawler. And the second goal is to get advantages of single-page application. So during navigation in application page, have not to be reloaded completely, and the code base has to stay the same, not reloaded each time with page request. Page has to be updated partially, only areas that need to be updated, and URL has to correspond current page state. It is a bit similar to isomorphic application built on React JS, and where first request for the page returns complete HTML from the server, and following navigation actions just fetch extra data and update initial page without complete reloading. Such design, where block dictates what functionality a page has to consist of, we may call block-driven. In other words, instead of using one big solid controller for the page, for the certain page on the client side, we use numerous smaller ones with a dedicated role, such as data grid, activity list, calendar, and etc. We call them page components. They have the same responsibility of controllers. They initialize modules and views, listen to and trigger mediator events, execute mediator handlers. Note that page component is not a backbone view. It should not manipulate DOM, change structure, or update attributes, or listen to DOM events. But before we get into specifics how navigation works in our application, how page components are defined in HTML, how initializes and disposes them, how to, and etc. Let's talk a bit about how the application is instantiated and how it can be extended. To understand how Chaplin application works, let's have a look at this diagram. Here you see that application initializes all main parts of it, including router, dispatcher, and composer. Then navigate history to get started. Navigation history gets started. Router match is found for URL. Dispatcher creates a new controller. First, dispatcher executes before action method. This method might return a promise object. Once the promise object is gets resolved, dispatcher executes the actual action method. Keep these steps in the diagram in mind, and we will return to it a bit later. Here you see an example of how the application can be initialized. This module is the starting point of application, similarly like app.php file in Symfony. Take a look how the list of required modules is defined. Part of it is static, and after it is extended with modules list in AppModule section of required JS configuration. These are specific kind of modules. They export nothing. They are created to configure application before it starts. This way, we make sure that all extensions of application are initialized at proper moment of time. Once required JS loads all dependencies and executes the definition callback, application is ready to start. App modules are defined in a required JS configuration. We add module name in app module section under config section of required JS configuration. This way, we are able to collect a list of module names defined across bundles. Let's have a look at a few examples of app modules. Here you see that we take a base controller and execute load before action static method. It is similar to require method of required.js, but it is not executed immediately. It will be executed at certain moment of time inside before action method of active controller. And in this particular example, we declare a new validation method in the validator. So some bundle can declare own validation method, and this method will be accessible in validator. In this example of app module, we add a register handler for mediator. here you see a show message handler is defined in mediator. And from any other place of application, this handler can be executed. And in this example, AppModule subscribes to global events, page before change and page after change layout methods. And in this last example of page component of AppModule, we define a composition of a global view. This AppModule will register composition with the name content in Chaplin Composer, and composition will contain an instance created by a page component view with options specified in last argument. Let's talk a bit about global views. Global views are views that initialized once at the application start. Or more specifically, before execution the controller action method. These views are persist in compositions and application in the application composer and stay alive between screens or application pages. See on the screen that here with the red border we see a page view, with green border main view and user view, blue border it's content view, purple breadcrumb view, and etc. There are numerous other views, and but the highlighted are most frequently used ones, and especially the content view highlighted with blue border. Now let's summarize the application start flow. First, we load the dependencies of required for the application to start, including declared app modules. App modules often register initialization callbacks that have to be executed in the before action method. When the URL is matched to the route, dispatcher creates a new controller that corresponds to the URL pattern. But before executing a related action, dispatcher executes special methods of controller before action. A before action method may return object, promise object, and if it does, original action method will be executed once the promise object gets resolved. We utilize before action method to, as you saw before, to register validation rules, register global handlers in mediator, subscribe events handlers to mediator, and create global view. And there might be other cases where app modules are useful. Once it is done and before action promise is resolved, dispatcher execute action method of controller, and the action method triggers series of page processing events. These events can be handled anywhere in application. Mostly they are handled in global views. You see example of such events. It's page before change, page request, page update, page after change, page error, and other. In route definition, there is only one pair of route and route mask and controller. This means that all pages are produced processed by the same controller. And here you see similar simplified version of page controller. Controller's constructor creates page model and subscribes to its synchronization events, request and async. Once the action method is executed, page controller will fetch a model from the server. If it is not the first, if it is not a first page request. If it is first page request, there is no previous route, meaning that no extra request is required and page already contains actual HTML. The controller will invoke on page load method. On page load method will trigger page update event globally to notify everyone page data is loaded and can be consumed by global views to update the page. The update promises variable with the empty array is passed as a last argument of the event. Any handler that processes the event can push a promise object into this array. This way, the next event page after change will be triggered once all promises are resolved. Some of them might be rejected. And now the application UI is ready to use, meaning that application UI is ready to use. In this example, you see that server response on the page request from controller. The most interesting bit here is component content property. It contains HTML for content area of page. ContentView listens to page update event and updates its HTML. After HTML update, the view invokes init layout method. This action is asynchronous, and promise object is created to handle the result. This promise is added to the list of other promises of page component. This way, HTML of page component is updated, and the controller will trigger page after change event only once after the page is ready to use. Let's take a closer look to asynchronous rendering. Rendering becomes asynchronous due to the init layout method. Once we call the init layout method, the result of rendering can be handled with the help of promise object. Init layout does series of action for layout element. Generally, a layout element, it is the element of current view. First, it's styles form elements. For example, initializes uniform widget where it is necessary. Initializes bootstrap controls such as scroll spy, tooltips, or popovers. But most importantly, it initializes page components that are defined in HTML. The last action makes the render method asynchronous. Require.js needs time to resolve modules of page components definition in HTML. In data attribute of an element, you see how data grid components is defined. First attribute is the module name of components, and the last one is serialized object of it. Serialized option object of it. Let's review an example of page component initialization. Imagine we have following HTML. It represents some reports with chat and controls to select the report's period of time. Note that these components are not real and you won't find them in Oro. They are made up just to explain how it works. As you see, there is three components defined. First one renders chart view that shows revenue changes for period of time. Second, initializes validator for the form. And last one creates two views for date pickers of start and end of period of time. Page component will have three independent components that are rendered that render their views. Chat component will render chat view with some diagram for initial period of time. Date period component will render date pickers view, and we will be able to select start and end dates. However, there is no exchange data between chart view and date pickers view, as they don't know about each other, and frankly they don't need to. The only thing that will work here is validation, because it uses DOM events to get notified about the changes, and picker controls element are nested inside of validation element, and changes will propagate up on the DOM tree. Please note, despite the fact that in HTML, DOM elements of period component is nested inside the validation component element, components are not nested. They are on the same level and belongs to page content view. So how to make chart view update once the period time is changed? The first thing that the developer could do is to trigger and handle global events on mediator. Although this will work, but this is not a good solution. If we would want to have a couple charts on a page with their date pickers, those events would intersect these reports. We need a different solution. Let's make dedicated component that will allow us to exchange data between a chart view and pickers views. That components have to wrap whole functionality. As you see, we have defined a report component on the top level. But it will also won't work. As you remember, despite the fact that in HTML components are nested, they are actually on the same level of parent layout. We need something to say that everything inside report view elements belongs to separate layout and will be processed separately. We have special attribute for it. According to it, the view created by report component will initialize the layout inside by itself. It changes initialization flow in the following way. First, page component will initialize its layout, but not go inside HTML market as separate layout. Report component will be created and will initialize a report view. A report view should call init layout for its own layout element, and it will initialize the rest of the components for the inner layout. If a report view don't call init layout for inner HTML, components inside will remain not initialized. So it is importantly to mainly init layout for separate layout view. And we will get following tree of components and view instances. Now we have dedicated view that can implement communication between charts and date pickers. However, it is still hard to do. Components don't have distinctive name. Component manager will give them default names. A report view is not able to distinguish one component from other. We can give meaningful names for components in HTML attributes. So here you see special attributes that provides names for components. Now report view knows which component is chart and which is report and which is period. Finally, report view is able to pass dates of period to chart once they are changed, once they get changed. But is not a good solution as well. It is highly coupled. What if a bundle add one more control to the form, for example, filter by source revenue? We will get following structure. Now report view has to know about source selector as well and pass the changed value to the chart view. Such solution is hard to extend, and we need a bus that will allow us to communicate control views and chart view directly without relying on a mediated view. Thanks to Backbone, we have it, and it is Backbone model. Source view and date picker view have to update attributes of a model, and chart view has to re-render the chart once the model is changed. But how to path the model to the components that are defined in HTML? Report component creates a model and passes it to report view. Now know that async rendering is notes how async rendering is handled here. The state of rendering is reflected in components initialization promise. Components initialization promise won't be resolved while render promise is still in pending state. Report view shares the model with its layout. Here you see that init layout accepts the model, and it will be accessible in child components, nested components. This way, the models gets accessible for chart view and controls view. Let's review one more time how initialization and rendering promises are handled. So first, we call render method for page component view of page content view once it handles page update event of the controller. Once the HTML is updated, page component view will invoke the init layout method and will pass the promise to the controller. Page component of report component will create a model and will create a report view and pass the model into report view, and then execute render method of report view, and we'll wait for a promise to resolve. Render method of report view will invoke initialize init layout for its own HTML and pass the model instance, and also will wait the promise once layout will be initialized. During init layout, 4 components will be created and will create their own views and render them, and will wait for promises to resolve, rendering promises to resolve. Some of them might be resolved right away, but some of them might take some time to get resolved. here you see that chart view resolve its render promise a bit later with some slight delay, and date picker, one date picker is still waiting for its rendering. And once all views are rendered, all rendering promises are resolved, page components will resolve their initialization promises, and this promise resolve action will get up to the page component view, and the page component view will resolve its promise, and page controller will notify that page component done its job. Okay. And one more thing. Often there is a need to just bind a view to an HTML element. Other actions are not required. For example, a validation component does not do anything but create a form validation view for the form element. For that purpose, we have ViewComponent. We can define a module name of the view, and that has to be initialized for the component, have to be initialized in the components options. So here you see that we used common view component and specify view module name of view that has to be initialized. Here is practical articles that we had before, and they are still actual, so I recommend you to see to look them as well. And this is pretty it. We done the job a bit later, so if you have any question, you are welcome. Please write into questions area the questions. Okay, so I think there is no questions, and thank you for attending the meeting. Hope it was helpful. Thank you. Bye.